Hi friends. Um, yeah, today's session will be a little more interesting. I just wanted to make you realize you guys that what is the right way to learn programming. How a programmer has to think and how a programmer has to analyze any program. According to me, most of the say 90 to 95% of the programmers they just know how to code, but the real fun in programming you can find only when you start analyzing and when you start thinking uh, on every line of your code. So today what I am planning to do is I will just take a simple example, uh, and then I'll show you how programming is fun when you start really thinking and analyzing the code. So let us take this simple example. So I'm just taking a very basic example, finding a Fibonacci uh, uh, value for a given input n. So the program is simple, just a few lines of code, not more. In fact, the function is not more than 10 lines of code. So for a given n is equal to 5, I am calling Fibonacci function by passing n, which will return the Fibonacci value, and I am printing the Fibonacci value. Also, to analyze the program, I am counting how many number of times that function is calling because I am using recursive call. So I am finding a Fibonacci value using recursion. Hence, I am counting how many number of times that function is getting executed. And then finally, I am printing the number of times that function is getting called. So let me start with value 4. So if I give n is equal to 4 as an input, and if I run the program, you can see, number of times that function is called is 10. And if I change the input as 5, that is 4 to 5, I'm just incrementing 1 for input n. See, here it is 10 for given value 4. Then when I execute for given n is equal to 5, 16 number of times that function is getting called. Now I will increment again n by 1, 6. See, now it is 16 for given value 5. Now if I give 6 as input, 26. For a given input n, it is calling 26 times. Now if I give value 7, I am just incrementing n by 1. Now see, it is getting called 42 times. For 6, it was called 26 times, and for 7, it was called 42 times. Now what I'll do, I'll just increase n by another 3, that is say 10. So from 42 to, let us see what will happen. For n is equal to 10, it is calling 178 times. Now here is the fun. If I just increment n by 1 again, that is 10 to 11. If n input is 11, remember this number 178 times. Now see, it is getting called 288 times. Just incrementing n by 1, the number of times that function is calling is drastically changed. Now let me give little bigger value, not too big. If I give n is equal to 21, we'll see what will happen. It is getting called 35,422 times. Just n is equal to 21. Now if I increase n by just 1, from 35 to it went up to 57,000 times. Very interesting. Now let me give n is equal to little bigger, say 31. Unbelievably, it is calling so many number of times. How many? 43 lakhs 56,618 times. Just think, just n is equal to 31. This Fibonacci function is recursively called 43 lakhs times. Now let me increment only one, 32. From 43 lakh to it went up to 70 lakh times. Unbelievable. So the fun part here is a simple C program which is not more than 10 lines of code. Without your knowledge, the program is behaving so weird, or it is executing so many number of times, even for changing n by 1, just one increment. This you will never get to know unless you really think how that program is working, how that program is really running, or what is happening in that logic. So let us analyze this, why it is taking so many number of times, what is going on. So we all know how recursive works. When you call any recursive method, the function will be calling by itself repeatedly unless it reaches an end condition where there is no more call, no more self call, but it will come out of the function. So it is continuously calling until it reach that condition. So here in this our case, we are putting this condition. If this condition satisfies, it just returns instead of calling again. And in this process, the recursive calls will make use of stack memory. So every call will be pushed to stack. So if you just visualize that part, say this is your stack memory. Okay, and so what happens when you call, sorry, so what happens when you call Fibonacci function? It will be pushed to stack, say fib of 4. If for a given value input 4, fib of 4 will be pushed to stack, and for this fib of 4 it will again invoke two times. Sorry for bad drawing. Okay, so it will be invoked two times. One is fib of n minus 1, that is 3, plus again fib of n minus 2, that is 2. And for this fib of 3, again it will invoke one more time. Okay, that is a fib of 3 minus 1, 2, plus fib of 3 minus 2, that is 1. Okay, and for this fib of 2, we spoke about this fib of 3 call, but there is one more call in this second call, that is fib of 2. For this fib of 2, again it will invoke one more time, correct, which is fib of 2 minus 1, that is 1, plus fib of 2 minus 2, that is 0. Similarly, for this fib of 2, one more call will happen, and for this fib of 1, another call happens, and for this fib of 1, one more call happens, and for this fib of 0, another call happens. Sorry, for this, yes, for this fib of 0, another call happens, and from there it will return, because it will reach the end condition. But see here, the interesting part is in this call we already invoked fib of 2, and this fib of 2 is again called here. It is a repetitive call, and we already invoked fib of 1 here, and this fib of 1 is again invoked here. See, what we are understanding here is fib of 1, fib of 2 is already calculated in second call itself, and we are again calling fib of 2 in the third call. Fib of 1 also already calculated in third call, but we are again calling in fourth call. That means the nature of program is it is repeating the calls unnecessarily. Also, because of these recursion and because of these repetitive calls, when n is becomes bigger, the repetitive calls will keep increasing, and it is keep pushing into the stack memory, and it is keep calling unless it will reach the final condition. So I have drawn a nice diagram to help you guys understand even better. So this is what happens for a given n is equal to 4. Fibonacci of 4 is called, and for this fib of 4, fib of 3 plus fib of 2, fib of 3 will call fib of 2 again, fib of 1, fib of 2 will call again fib of 1, fib of 0, fib of 1 will call again fib of uh, uh, yeah, it will just return from there, and then fib of 0 will return from there, and for this fib of 2 again there is one more call. So it will increase like that, and until all the calls will return from by reaching the final condition. Now just for n is equal to 4, we are seeing these many calls happening. So that's what we analyzed in when we were executing the program. So now n is equal to 32. If you start drawing this diagram, you will go mad, because it is calling 70 lakh times, which is really um, terrific. And now if you make this if you think even little more, if you start applying a simple basic mathematics here, you can easily make out, if you plot a graph for given input n versus the number of times that function is getting called, you will see a drastic change after reaching certain input n. That is, it is kind of exponentially varying. For given input n, smaller value is fine. As it is going bigger, it is increasing drastically. So the program is behaving exponentially for given input n. So this is very dangerous. Exponential growth is always a dangerous growth. So what we understand with this simple recursive program is, uh, I will uh, uh, I will quote a typical quotation by Albert Einstein, that is, imagination is greater than knowledge. So Albert Einstein said, imagination is greater than knowledge. So here, in our case, in this program, the knowledge is what you know about recursion. Everybody knows about recursion. It calls by itself until it reaches the final condition. That is your knowledge. Also, you know how recursion works. Um, Pushing into stack, um, returning, all those things, how the stack memory is being used throughout the process of recursive call. That is your knowledge. But also, the knowing about Fibonacci, you know what is the Fibonacci, how to calculate Fibonacci, uh, that is your knowledge. But if you really want to know whether recursion is appropriate to apply it for finding the Fibonacci value, that is where your imagination will come into picture. Unless and until you really think what will happen if I use recursion for finding a Fibonacci value, if you don't go into that imagination, or if you don't try to analyze how that program works, then you will miss that fun part of that program. So I think this is a great quotation given by Albert Einstein, that is, imagination is greater than knowledge. Thank you guys. I hope we learned